Oh, this is back after a week. Way to let me know you're going to be gone for an entire week. Well, aren't you supposed to like try to get your work? I suppose you're just going to school, did you?
Yeah, because I knew it was a bunch of video.
All right. So section 7 is where we're going to learn a lot of the rest of integrating. And it's called integration by substitution. I got some questions on, what day did we meet? Wednesday? Oh, yes. So on Thursday, the other calc class I had asked me to make up kind of a little sort of a schedule for them for reviewing to try to make sure that they would be done reviewing by the time the AP test came around. So on the back wall, I kind of put like just a generic outline for you guys. So if you want to basically try to review everything before the AP test, that would be kind of a rough schedule to do. So like say this week and next week, I would try to review all of limits. And my guess is you forgot a lot of that since it's been so long. So I would probably take 2 weeks on that. And then the week after that, unit 3-4 is the beginnings of derivatives, which I'm guessing actually will feel pretty easy for you now since we kind of worked on the more difficult derivatives consistently. So reviewing 3 and 4 should go pretty quick. And then kind of unit 5 and then unit 6. And I don't really think you're going to need to review 7 and 8 because we're basically going to be learning them and doing them as we work our way to the test. In terms of what you'd want to review, you know, it 100% will boil down to how much time you have. That's usually what happens. It's not necessarily about like motivation or anything. It's just how much time you have because you guys still have normal homework. If this is your only AP class, well, then trying to study for one AP test isn't bad. And I know a lot of you traditionally sign up for more than one. And some of you are even like cruel to yourself and sign up for like 3, 4, 5 of them. So in that case, then it's really hard to manage time. So that's just a general outline for you guys to go by. I would focus study on what you want the most. The AP classroom is probably going to be your best bet if you're only going to be able to study one thing. And then that one is just because it's put out by the AP themselves. I've unlocked everything for you. So there's, I can't remember what they call them. Progress checks or something is what they call them, I think. Basically, they have little quizzes for each chapter. They have practice AP tests. They absolutely have videos to go with every section. And then they also have, bless you, they also kind of have I think it's 16 days. I can't remember how long it was set up for. But they basically have a review for the AP test set of videos. So like one day they'll just go through like all of chapter 1 and so whatever you're able to do, just kind of plan that or set that up ahead of time, it'd be good. And if you want more resources, more everything, certainly just ask, and I know quite a few. So anyway, I didn't want to forget to tell you about that one. So integration by substitution, let me kind of start off with separate here. Oh, that one was actually pretty good. I'm kind of impressed with that. Is it like time for colds again or what? Uh-oh. I suppose it may. I was going to say, once spring starts too, that's. Everybody's sneezing all of a sudden. Oh. I got the new dice in finally. Should we roll to see who's going to roll today? 2, 5. 2, 5. Caden. We've got the Eastridge black and gold metal dice here.
Yes.
Oh, they look fancy.
Those are actually very fancy.
They are.
How do I read these?
The triangle one, you read the number on top.
Okay, and then this one, just whatever.
Whatever number's on top. Except we don't have a 0, so.
Reroll. If I get a 0, because we don't have a 0. Okay.
Or we can make it your choice or something. It doesn't matter. If you get a 0, you can just read off any random number you want, maybe.
Oh, okay.
It's a good way to pick on your friends. Yeah. I say random, but I'm sure you'll be targeted.
So I'm rolling.
Yep, roll.
3, 5.
Lily? Do you think you could help me integrate that?
I think so.
Okay.
Okay. Add 1 to the exponent,
Okay.
and then put it over 4.
Okay. That's it?
Plus C.
Plus C. Good, 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 good. Okay. So we've done quite a few of these. Excellent job. That's all there was to it. I wasn't trying to like look for hidden meaning or anything. Where we're going now, though, is these are going to be represented by other things. So I put an X up there because we're used to that. But integration works the exact same thing no matter what variable is there. So if it was a U, same answer. And yes, I know my U looks like an N a lot of times. I can't help it. To me, it just looks ugly to write that, so I don't. Well, that U can be represented by a lot of things. So all three of these are considered the exact same problem. And that's because all three of them have the same information. If this is our U for U substitution, so when you're looking at this, you should look at it as something cubed. This would represent the derivative of that something. So this whole thing right here is considered the derivative of the item that was cubed. And so if you have an integral of something cubed and its derivative present with it, then the answer would be that something to the fourth divided by 4 plus c. So this is what's going to be the U substitution. What do you guys need? Oh, okay. I was going to say, you're having a lot of trouble starting. Multiple people have a lot of trouble starting and focusing here. This is what's going to be this entire section. This is what's known as integrating with substitution. For you to excel at this topic, you have to be very good at doing derivatives in your head kind of quickly. And we practiced derivatives a lot for this very reason. So if you see x to the fourth minus 3x squared plus 6, you should pretty quickly be able to figure out that that is its derivative. Like, are we okay with that? Okay. Now I gotta try to think of them off the top of my head. Let's roll for this one.
Let's do it.
This is probably a very evil roll, but we're going with it.
Alright. 3-1.
Thoughts? I can absolutely guide you 100% of the way. I just thought I would give you an opportunity to, if you were able to spot things right away.
Would it be tangent U over 3?
Very nice. Very nice. And what you're supposed to be able to recognize out of this, and honestly, I'm impressed you did right away. That's pretty good. Is you're supposed to recognize that the derivative of tangent is secant squared. And if you recognize that, the way that we're going to show this, okay, not everybody is going to be very good at doing these in their head. I will absolutely say that right away. Some people are terrible at doing this in their head. Some people have a really hard time not doing it in their head. I've noticed a very distinct separation over the years of doing calc that it's just the way people process things. So some people, what they're going to do is off on the side of the problem, they're going to say let u equal tangent of x. And then from this statement, they're going to figure out what would be the derivative of u. And so then they would know that it's secant squared x dx. And then you're going to literally replace things. So in place of tangent, you're going to put a u. In place of secant squared x dx, you're going to put du. And then on the next line, you would write it as u squared du. And then from there, this, for some people, they need to do this to be able to kind of like visualize it. And if you do that, then you would know to integrate u squared is just u cubed over 3 plus c. And then once you integrate that, you then replace the information back in place of u. This is kind of what this entire section is about. Now, I'm not going to pretend that you're going to get it right away. Like, I'm sure some of you have, because I noticed last week that a lot of you were working ahead, which I don't have a problem with at all. Once you figure it out, it does make a lot of sense. But 100% until until your brain can like picture what's happening, it has a lot of trouble comprehending what's taking place. If we had an ideal schedule, I would take quite a few days on this. Like, there's no way I'm going to pretend that you're going to be experts at this after 2 days. We also don't have an ideal schedule, so do the best we can. This was another reason why I thought it might be okay to test after the AP test, because then this way you absolutely will have time to practice lots of things before you test. But in short, this is what we're doing. Now, I purposely wrote this in kind of a substitution-friendly notation. This would not actually be written like this. What did I have, squared or cubed? Thanks. This question wouldn't be presented like this to you. It would be presented like this. And even though that's just a minor difference, for most people that's harder to visualize what's happening. And that happens with trig. Yeah. It does. So that's why I presented the problem like this, because I knew it would be easier to visualize. Okay, do we feel like we're ready to be able to start the section probably? I see. Is this 0 to 5? How are you feeling on the topic before we really ever do any of these? I can't tell if a lot of you are just super apprehensive or if. Oh, why are you so quiet today? Usually you're absolutely not. Monday happens every week. It's not like a rare thing. We didn't come back after 2 weeks vacation or something. Okay? All right. Well, let's do these. Oh, wait, what happened to the first page? Actually, we don't need to. So the ones that I showed you were kind of like perfectly set up to start with, and most of them are not going to be. And that's why it's going to be helpful for us to go through these examples to show you what happens when they're not perfectly set up. Okay, Caden, we are ready to roll.
4, 9.
Feel like you're ready to help? That sounded super confident. Okay, so on A, we've got the integral of x squared plus 1 squared 2x dx.
Oh, x squared plus 1 cubed over 3.
Nice. Okay, so you basically just gave me the answer right away, and I'm totally okay with that. Do know on a test you are able to do that. Okay? We're going to purposely practice the u substitution for a little while here, though, because some questions you have to do it on. So you did it perfectly because I think you recognized that this, or 2x was the derivative of x squared plus 1. That's good.
Just a quick question. On like the AP test and stuff, or maybe like the test in this class, would they fully simplify that x squared plus 1 squared 2x all the way down, or would they just keep it like that? Like, parentheses or factors?
You mean like would they FOIL this out and then multiply by 2x?
Like, would they just fully simplify it down to, so it's like,
Are you talking about the answer or the original problem?
like the original problems where it's like within the sign?
Either way. Honestly, if it's simplified down, if I think I'm understanding you correctly, if they FOILed out x squared plus 1 and then multiplied by 2x, that would actually be a super easy one to integrate because it would just be individual polynomial terms. So my guess is they would leave it like this and then kind of give you the choice, because you could do that too if you were really stuck. So because you recognize 2x was the derivative of x squared plus 1, that means x squared plus 1 would be like our u substitution, and then du would be 2x dx. And again, if you can do these in your head, I'm okay with that. But I want to purposely practice the substitution part. So by us writing this, the problem becomes integral of u squared du. Now, do you guys want me to kind of like physically show how to... Do you want me to physically show how the substitution happened, or are you guys pretty good at picturing that? Yeah, I can do it for more than one of them even, yeah. So x squared plus 1 was what we wrote for u. Whoa, that's not what I want to do. X squared plus 1 is what we wrote for u, and so I would put a u in place of that. And then 2x dx was the derivative, so that's what I would put du in. And some people are good at doing this in their heads. Some people have to write it out. It's just the way everybody is. And then from here, you just integrate like normal, and you'd get u cubed over 3 plus c. I know you didn't say plus c because you were focused on the hard part. You will be shocked how hard it is to remember to write plus c. And u is our substitution info, so we don't leave that in our final answer. Our final answer shouldn't have a u information in it. So then we would say x squared plus 1 cubed over 3 plus c. I'm pretty much guaranteeing I know you guys want to do trig ones together. Okay. Sure, Caden, let's I don't know if it's cruel to ask this or not, but let's just roll somebody for B.
4, 2. No, 4, 4.
2, 3, 4. That's Lucas. Lucas, what would we use for like the substitution here?
4x.
Okay, how come not cosine of 4x?
Because the derivative is 4 as well.
Okay, yep, I mean, yeah, like it's probably hard to explain. If I chose cosine of 4x as my u, what would the derivative of cosine of 4x have to be?
Negative sine 4x.
Negative sine of 4x times 4. And I don't have a sign written anywhere up there. So I know that that can't be my u substitution. The only thing I do have present is a 4, which is the derivative of 4x. And so for my substitution, I have to pick something that has its derivative info there. So my u is actually just going to be 4x. And then the derivative of 4x would be 4 dx. And I know we never really said dx, but we all know that dx is 1. So actually substituting things out, this would be u, and then the 4, and then the dx is du. It's not really a good way to, like, for me to write that up there. So this will become the integral of cosine of u times du. And, oh, no, I should call on somebody for this, even though this is kind of fresh for you, and you guys have basically haven't had calc for almost a week. Caden.
Dice.
Yeah.
4, 1, 4.
Ryan?
Sine of 4x plus c.
Okay, not negative sign? Good. It is sine of u for right now, but yes, what you said was fine. So sine of u plus c, and then we knew u was 4x. I only tried throwing you off with the negative sign part because I guarantee that's what you guys are going to be like trying to think to yourself. And it's going to take a little while to get that straight in your head. But very good. Because of time, I don't want to do C or, no, we definitely are going to do D. But I don't want to do C because it's actually, do you want me to go over how to set up C?
Yeah.
Oh, okay. That's fine.
Why do they get 2 bells?
One for each lunch.
Oh, actually, oh no, I'm thinking of the other days. I think the first bell is for the kids to leave for lunch. The second bell is for C lunch? B lunch? B lunch kids to start class. Yeah, because this is C lunch now, I think.
Yeah.
Yeah. When I recognize that 8x is the derivative of 4x squared plus 1, I would make u be 4x squared plus 1, du be 8x dx. Bless you. This is going to be the square root of u du. And we wouldn't use square root. We would write it as u to the 1/2. And I'm pretty sure most of you will be able to finish it from there. Then it's just power rule. I wanted to get to D because D is the first one of the ones that's not set up perfect. And there's 2 methods for doing like D and E and probably F. Yep. Probably the rest of this page. The examples we've had so far have been set up so that the information that was there had the perfect derivative with it. And that honestly doesn't usually happen. It can, but it doesn't usually. So when we get to D, D is one of the ones where it's close, but not perfect. So x squared plus 2, if I make that my u substitution, its derivative is going to be 2x. But I don't have 2x over here, I only have a regular x. So x dx is what's in the problem. What you're going to want to do is solve this equation for x dx. Because if you're doing substitution, you have to substitute things out perfectly. And because I don't have a 2x up here, I just have an x. I'm going to divide both sides by 2 and make it say it's equal to x dx. And now when I do my substitution, this is going to say u cubed. And then instead of x dx, I'm going to write du over 2. Now that over 2 seems like it should be kind of messed up, like, whatever. But over 2 is the same thing as like multiplying by a half. So what I'm going to do is, this is a multiplier. I'm going to bring it in the front. And then now my equation is set up to integrate. Okay, I noticed my u also looks like a w. How is this one? Does this feel a lot harder doing that part? I mean, ask away. If I can see a lot of you are fading since it's after lunch. Casey. You're not the only one. So no questions on that? Yeah.
How do you know what the U is and the U is?
Practice. There isn't a great way. There's not going to be a great method for me to say, other than you have to be able to quickly recognize what the derivative of something should be. So like when I look at that, because they're dealing with powers, right? When you do derivatives with powers, the derivative has to be a lower power. So I would automatically know that x squared compared to the x would kind of have to be the original. But not everything is powers, so it's not always going to be something that easy. But yeah, I absolutely, that is something that a lot of people get stuck on, and it takes practice. Okay, I told you there's 2 ways to do this one, and so I wanted to wait if there's any questions before I erase this. Okay, erasing. I'm kind of curious, how many of you, I guarantee some of you just do these in your head probably, right? Some of you like to write out the u substitution, some of you like to do it in your head. If you are a person that does not like writing out u substitution, the other method you have is to make this a perfect derivative. So you recognize that the derivative of x squared plus 2 should be 2x. So I'm going to put a 2 there. But I can't just randomly put a 2 there to make it correct. So what I'm going to do is I'm going to multiply by 1/2 as well. So if I multiply by 1/2 and 2, it doesn't actually change the problem. because you're kind of multiplying by 1. But you choose to do the 1/2 out front and the 2 on the inside. And once you do that, this is now the perfect derivative. So that's the kind of like the other method that I did not see written in the notes, like in the packet. So for those people who went ahead and were kind of working on some of these last week, you really wouldn't have seen this method. If you are a person that likes, thinks quicker in your head, and writing down the U substitution kind of actually slows you down and screws you up, this is generally what you're going to do, is you're going to know that you need to make it a perfect one and counteract by multiplying by the opposite. This method only works if you're multiplying by a number, though. You can't multiply by a variable. It's only numbers. Okay. Do you guys want to try E on your own? Are you ready for that yet or not? Wow. You guys are just making it awkward in here today. Was prom that bad? Was it just huge drama between everybody and now everybody hates each other in here? Is that why nobody's talking? Because that's pretty much standard for prom. Okay. I'll give you guys 2 minutes. Try it on your own, and then we'll start calling on people to answer it. This is all the farther we're going today. We're not going to go into the rest of the section.
Lower power. Wait, these are negative. Should we bring it up?
You should. Yeah, Grace, you have a lot to catch up on. I doubt you did any while you were gone, but yeah. So it's not a lot of sections. It's just a lot of info. But you got win time now, so we're good for catching up. Yep.
That's what I was trying to think. It's divided by 8. Yeah, oh yeah. Didn't he make it? Yeah, he made it from the
Grab a bunch. Uh, 60 seconds. And if you're not done, that's okay. Just do what you can. You're saying correct things over there. What? Oh, you didn't want to roll anymore?
Oh, we're still rolling?
Yeah.
Oh, okay. Never mind.
I was going to call on people to help me figure this one out.
I would love to roll one.
Okay.
Oh, yeah. You can roll one of them.
All right, Teddy, who's going to help us start?
He's not gonna get it. Call you.
4-1. No.
That's nobody.
3-0.
Casey, you got rolled. So what I want to start with is the most important thing on these problems is what did you identify was considered like the main u, and what did you identify as like its derivative?
The main is 4x squared plus 3.
Good. Doesn't matter that it's on the bottom. That's correct.
And then the derivative is x dx? Or x over to 1? I don't know.
What would be the derivative of 4x?
Sorry.
Yeah. That's what I said. I remember hearing you say sort of like the correct things over there.
And then do you have to put an 8 on the top with the x, and then on the outside do 1/8?
You can. That's kind of like a hybrid of the two methods, but it's not wrong. So if you put an 8 out here and a 1/8 out front, then the u substitution would work correctly. That's basically like an exact hybrid of the two ways.
How did you get that du? I don't understand where that came from. Because I know that the derivative would be 8x, but what do you do with the x on top?
Oh, you're talking about in the problem itself.
Yeah.
Okay, I thought you were asking where the 8x came from. Got it. Okay. The x and the dx is part of du. And so I would solve for x dx. So I'm not going to write your way because from what I've seen over the years, most people need to do like hard substitution rather than, but that will work doing that. So I'm going to solve this for x dx, and it's going to say du over 8 is x dx. And what kind of throws this one off is the fact that it's in the denominator. What we're going to do is we're going to write this in the numerator with a -6 power. So
Just confused as to why the du was written as 8x, but there was an x on top, so I didn't know where that came from. But then I understand that then she put the 1/8 in front. So.
correct, yep. Yeah, an x on the top is like multiplying by an x. You can write it at the end if you'd like to as well. So we have 1/8 integral u to the -6 du. No matter which method you do, you should have a 1/8 in the front. Like, it doesn't matter if you're doing substitution or mental substitution, you should have a 1/8 in the front because it was missing an 8. So this 1/8 in the front kind of counteracts that. Okay, so then we'd have 1/8, and then this is going to be u to the -5 divided by -5 plus c. And I would write this as -1/40. U was 4x squared plus 3. It doesn't matter if you write -5 power in the final answer. I bet you a lot of answer keys will write this as -1/40 4x squared plus 3 to the 5th. But you absolutely don't need to do that. Like, there's nothing wrong with leaving this as your answer. So if you ended up with this on your own, very nice job. That's basically all the more difficult you'll get. Like this one, it's difficult to see the du because they're separated in different spots. Little things like that kind of add up sometimes. So if you got this, that's good. Choice F. I wrote it how you should view it. I know in the past, the root and the power, it's kind of hard for some people to visualize what you're supposed to do with that. This is obviously going to be u. This is going to be part of du. So you're going to have to kind of fix it, or it's going to be modified. Okay, I didn't want to go too far today because I know you're going to need practice at this. I believe the next page was definite integrals, wasn't it? It's not. Oh, I screwed up timing. Yeah, do you want me to do trig tomorrow?
We can do like one or two.
No, I'm okay separating them because it's almost like you have to think of them differently. So I think what might be best, the definite integrals is not hard. Like, that's not going to take me long to show you. Why don't you guys try to get practice in the packet homework on indefinite integrals with powers? If there's indefinite integrals with trig, you can hold off on that unless you know what to do. Other than that, don't do the definite integral ones yet. I bet you could come up with the correct answer, to be honest, but you would write it incorrect and get it wrong on the AP test. So don't do the definite integral ones yet.